My name is Oleg Zhurakousky, and I'll be talking to you about Spring Cloud Function today. Before I get into any details, how many of you were in my presentation yesterday? Very good. So I guess you want to know more, right? So for those of you who were there yesterday, some of the stuff that I'll be talking now may be repetitive because yesterday we talked about Spring Cloud Stream and eventing and how Spring Cloud Functions or functional programming can help you. Now we actually get into the internals of Spring Cloud Function as a project, as a framework, kind of another deep dive sort of a session. I don't know how much of the details I can cover, but I'll try to do as much as I can. I have like a plan, but with the demos, but however many we can hit, we'll see. Again, as yesterday, a few slides, and then we'll start coding. For those of you who were not there yesterday, again, my name is Oleg Zhurakousky. I've been with Spring twice. Once in 2008, I joined SpringSource. Then I left in 2012. During that time, I worked on Spring integration as an engineer. And how many of you are using Spring integration? Very good. And I came back about 3 years later to Pivotal, to the same team, and now I'm leading Spring Cloud Stream and Spring Cloud Function project. Dave Syer is here, the founder of Spring Cloud Function project, and the founder of many other projects in Spring, so I'm kind of have a big shoes to fill, but hopefully I'm doing a good job. Quickly about myself, I'm originally from the most famous country on the planet. You want to guess? Ukraine, exactly. Came to the United States in '91, and now I'm living in France. Don't ask why. So, all right, let's begin. So, Spring Cloud Function. This is kind of a quick agenda, what we're going to be talking about. So, yeah, my microphone. So, why functions and why Spring Cloud Functions? What is Spring Cloud Functions, and how we use Spring Cloud Functions? So why functions? Well, the better question is why not, right? So think about what function these three strategies actually give you, and look back at your, try to analyze your requirements, the ones that you worked on, the ones you're working on currently or may work. I mean, these three interfaces, whatever you do in your programming world, you always either produce data, consume data, or produce and consume and produce data, right? Is there any other use cases? Right, so if you really abstract yourself far enough, then pretty much everything that you work on can be mapped to either supplier, function, or consumer, right? And that brings a very interesting paradigm, because now those are the interfaces that come with Java, right? So, and now not only you can implement them, you can just throw Lambda that looks like a function supplier consumer, and that will work as well. So the bottom line is that these are pure Java interfaces. They don't require Spring, they don't require anything. You can implement your functional requirement, and then you start looking at the frameworks, and that's really the value proposition of a Spring Cloud Function, which we'll discuss in details in a few minutes, is that if you have a function, I can do a lot of things with it. Okay? So if, in other words, it's almost like a canonical or uniformed programming model that it gives you. So why Spring Cloud Function? Well, before we get into why Spring Cloud Function, let's figure out what is Spring Cloud Function and what does it give you. So I just mentioned that it kind of gives you the additional value. So what those values are. Again, it promotes the implementation of business logic as functions, primarily supplier, function, and consumer. As I already mentioned, it gives you a uniform programming model. And some of the new features that we've been adding in the past 6 months is transparent type conversion. And I kind of alluded to that yesterday. I'll demo it today, which basically means that your function may have function Poacher, and you may provide, especially when it comes to remoting, streaming type of environments where you transmit your object in the form of a JSON or something, we'll do the conversion for you so you don't have to do all that boilerplate code, so you can keep your function domain specific. Function composition, which is an awesome feature because I keep saying it, I think Rod said that, but there's no such a thing as a complex problem. Every problem, complex problem is just an array of simple problems, so you have to parse it out like this. And again, with function composition, you kind of can do that now because you can implement your individual requirements as functions. You can test them as such. You don't need Spring for that. You don't need anything for that, right? And then something like Spring Load Function will allow you to compose them, chain them, whatever word you want to use, and now you're essentially creating a synthetic function that is a composition of several functions. And we will see that in a few minutes. What's also interesting is that there's different style of functions. Yesterday we talked about streaming event processing as well as simple event processing. And streaming event processing involves streams, like Flux or something like that, right? So what if you have a function that is imperative, another function is a stream function? Can you compose them? In the real world, no, because function and then function and then function requires type compatibility, right? But Spring Cloud Function you can, and we'll see that in a few minutes. What else? Poacher Function, that's a new feature. So basically duct typing. If it looks, smells like a function, it's a function, right? So in other words, while we're promoting or trying to say, listen, implement everything as a function, that doesn't necessarily mean you have to say my function implements function. If you follow the convention, which function means that if it's add functional interface, essentially, if it's a class with a one public method that, let's say, returns value and takes value, we'll treat it as a function. Arity. This is, again, a new feature, was primarily driven by Riff, which is basically functions with multiple inputs, multiple outputs. I showed a little bit of it yesterday. We'll dig in a bit more today. Deployment of package function, another great feature of Spring Cloud Function. So we can literally deploy, if you have a jar that has a function, we can deploy it. In other words, you don't have to pull your function out, create new project or whatever. All you need to do is just create a new project, put function deployer on a class path, and point to your jar. And we'll deploy it, we'll load it into, well, I'm skipping too much ahead right now. And last but not least, integration with serverless platforms like AWS, Azure, and OpenWhisk, and so on. As you can see, there's a lot to unpack here. So in 1 hour, I'll see how much I can accomplish, but I'll be hanging around throughout the day so you can catch me and drill me for more. Okay, last slide before we get into coding. So when you're working with Spring Cloud Function, there's only really two interfaces, two strategies that you have to be familiar with. The first one is the function catalog, which is like the primary place where the functions, how you interact with functions. You get them out of a function catalog, okay? It essentially acts as a function registry. It wraps functions and to add additional features such as composition, type conversion, and so on and so forth, right? And another one is a function registration, which is you may not always need to interact with it because it's kind of for the edge cases where you want to be able to, but the bottom line is, like, let's not even discuss the edge cases right now. The bottom line is function registration is the way to register function in function catalog, and it encapsulates all the information about the function. And the reason why it's important, because again, everything internally within Spring Cloud Function, we try to stay uniform. So in other words, when you're dealing with a simple function like function bean, as we'll see in a second, we internally will still wrap it in the function registration. So everything internally is a function registration because it's an object that contains it's like meta information about the function. The target, the input types, output types, how many inputs, how many outputs, and what have you. So, and a lot of times it's used for manual registration of a function. However, I can't come up right now with a case when you want to do that. But anyway, so, all right. As I said yesterday, I don't wait till the very end for questions. I prefer them in context, so please raise your arm. I'm scanning, so. All right. So again, just to save time, I prepared a few things, but we'll code some things in advance as I go along. So what we're looking at, by the way, guys, on the back, can you see the code? All right. So we have a simple Spring Boot app. There's nothing new here. We're creating application context. We're getting function catalog. So again, it has Spring Cloud Function context on the class path. Okay? So that's a context will bring core, and then you get everything. So and now you can. That's how you're going to get function catalog. So function catalog is going to be registered through auto configuration. So you don't have to do anything for that. And now I'm doing function lookup. I'm providing an empty string, kind of starting from very scratch, and executing this function. Now, it's maybe confusing, but if you look at my configuration, and believe me, it's still in the configuration right now that's available to the Spring Boot configuration, I only have this function uppercase. So it is the only bean of type function in my configuration, right? Remember how I said yesterday, we try to limit configuration as much as we can. So the boot mentality is, we have an opinion, right? As long as we can, if you agree with our opinion, then go ahead and run with it. If you don't, as long as we provide ways for you to back out, we're still friends, right? So our opinion, if you only have a single function, you really don't have to provide me with a name, because I can discover that. Because my opinion is that I think you intend to use it, right? So I can look it up as a empty string. We probably should override the method, just do lookup with nothing, but if I run it, we got hello, okay? Now, obviously, if I do uppercase, it will do the same, okay? Yes?
Accustomed to expecting in Spring that you would have to inject the function catalog somewhere.
Yeah, auto configuration, it is injected. So remember, we live in the Spring Boot world, okay? Which means that whenever you throw something in a class path, there is a boot magic, right? So there is some auto configuration that comes with, when you add Spring Cloud Function context to the class path, something happens, right? Yeah, but the function catalog is already part of the application context, right? So anybody want to ask a question? I kind of expect that there is a question looming here. Let me try to lead you to the question. So go ahead. Say what? Well, we're getting into sort of a performance of initialization application context. That's really topic in and of itself, meaning that it depends on how complex your application context is, but there is another feature of Spring Cloud Function specifically, well, not Spring Cloud Function, but rather Spring Core, is the functional bean registration, which is kind of out of scope for this presentation, but in other words, there are ways to, if you need to improve initialization time application context for whatever reason, then, right, Dave, functional bean registration, that's the feature of Spring? Yeah. Right. So, but I mean, again, the question on the faster, like, what is fast, what is not? Like, how much is fast? Yes?
So, where is the registry of the function is occurring?
Well, that's close to the question, I want to say. So, first of all, this function is a bean, right? So, the registry itself, in this particular case, is application context, bean factory, right? And the question I was kind of leading to, so, okay, if the bean factory has a bean of type uppercase, can I just simply do this? Can I do this? Why not? It's a bean. Do you think it will work? Let's try. And of course it's going to work, right? So why don't you need function catalog then? Well, because I'm giving you the simplest of cases, right? There's really nothing for this specific function, for the way I'm invoking it, there is nothing absolutely that the function catalog will do for me here, right? But it provides that uniformity, right? But we're going to get I'm going to get into the type conversion case, and that's where things become a little more interesting. So let's, well, before we get there, let's introduce another function, public function okay, so and again, try to look it up by default name, so to speak. I got null pointer exception when I try to see a function apply, because what this had returned null. And if I look at the message here, it says looking up function with found more than one function in bean factory, uppercase and hello. If you did not intend to use function, ignore this message. But if you did, this is something, one of the issues we kind of discovered yesterday, because we try to use this as a feature, but sometimes when you have a complex project configuration, you may have some bean that is of type function. You never intended to use it, but anyway, or some beans of type function. So at this point of time, prior to, let's say, yesterday, we would throw exception, but right now it just ignores it. So that's what you call presentation-driven development. Stack Overflow-driven development, yes. All right, anyway, so now at this point of time, basically what I have right now, I have multiple functions, and now I have a tie, which means I have to break it, so now I have to explicitly specify whether I want to do the echo or uppercase, right? But again, as you can see, at this point of time, we're only dealing with the simple functions, and you could technically get it as a bean from the function catalog. But let's start getting into the weeds. Streaming functions. We didn't talk much about them yesterday, but Reactor, which is being talked on in the next room, Reactive is a big thing right now, not necessarily because it's a new cool toy, but rather because it allows you to, it may be complex to grasp at the beginning, but it allows you to solve certain use cases that would be very hard to do with imperative style programming, right? So like, for example, yesterday, I'm trying to find a good function. Okay, let's just get into the aggregator. So aggregator is a function, and again, like yesterday, I already have, like, let's say, let me step back for a second. One of the benefit of function that I did not mention, again, is because they're pure Java functions, doesn't require anything, it gives you the interesting way of distributing your teams. I mean, yes, to work with Spring Cloud Stream functions and Spring Portfolio, you have to be familiar, you have to be knowledgeable, you have to be experienced with it, right? But to write a function, all you need to know is Java. True? So, in other words, within your organization, you may have an army of junior developers who say, listen, maybe it's going to be a long road for them to learn some of these new technologies, but at least for the time being, they can get their feet wet by writing functions that will be then shipped to you, and you can include that packaged in a jar file, you can include it in the class path, and you can start using them when you're configuring your application. So it's almost like you have roles, where you have a developer of the function, then you have application developer that will create an application using the functions that were developed by other developers. So in this case, I kind of emulated that. So I have another project which is on this class path, and this project provides a static class called function lib. And this function lib defines some of the complex functions that I'm going to be using today. So in this case, I can define function like I did here in line, or I can basically say, here's my bean of type of this type, which is flux integer, and instead of just implementing it here, I just say, well, give me that one, okay? Or you can do new class, whatever. So it's called Aggregator. So I'm gonna do the so now I'm going to invoke it, and I have a method here that will generate, where is it? Where did it go? Oh, generate flux. I'll uncomment this. So this method will basically keep incrementing an integer, and so on, continuously, never ends. So it provides me with a stream. But let's look at for a second what this aggregator actually does. What it will do, and this is where it gets into complexity, and this is important again because, again, you have a very complex problem here. You're trying to say, I want to receive a bunch of different events. I want to accumulate them, in this particular case, in 5-second intervals, and then I want to perform some kind of evaluation on them. In this particular case, I'm only filtering the even numbers, throwing away the odd numbers, and then I'm reducing it, combining all the numbers counting all the numbers, and so on and so forth. So again, trivial use case, but hopefully demonstrates the complexity of the problem. So you can only imagine what you can do with it, right? So, and in this particular case, while I'm invoking the function, I'm passing the stream, not the individual elements, not the individual data. So, okay, so let's execute this. Where? Aggregator. Well, sometimes I like to look at the errors too, and they help you. Actually, it's like one of the Spring thing, like especially in Spring Core, and we kind of got infected by it in Spring integration, and I'm trying to mimic that in Spring Cloud Function with these explicit messages that tell you what's wrong and how you can fix it and so on. So anyway, so let's run it. I have a little system that added print line, so we're going to be seeing some numbers on the so the integers are going to be produced every 200 milliseconds, right? But we should see the output every 5 seconds. Buffering, 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 buffering. Demo gods, all right. Oh, the process terminated. It's a very common reactive mistake. Flux reactive is asynchronous, so my program just exited. So the old Java trick. Right, now we're going to block there and 1, 2, 3, 4, 5. Round 2. I love when the audience, I did it on purpose. I'll be like Trump, always right. No. Sorry. Why is it like when you're on stage, you're doing these bonehead mistakes? Okay, 3 is the charm, right? There we go. So, and hopefully the numbers that are going to come up are going to be all even numbers because we're only adding even numbers. Right? So all of a sudden, here's an example of a complex function. So now, this is a complex function. So this function is a flux function. The previous function was just a pure imperative function, right? But what if we do this, right? And this is where we start getting into the value of the function catalog. And I'll explain to you in a second why this is important. So let's change this function. We know that uppercase is flux string string, right? I'm sorry, function string string. It's an imperative function, right? But what if I do this? Do you think this is going to work? The answer is it will work. So in other words, you have imperative functions, but you can invoke it as a reactive. Now, okay, cool. Why is this important? Well, for a variety of reasons. So let's do this. So now you saw the part of the function catalog. All right, so we have uppercase, and I also have this reactive uppercase, which is the equivalent version of the uppercase, but in the reactive version, right? So the reason why this is important is the ability to invoke non-reactive function as a reactive function, because let's look at this one. I'm going to do the reactive uppercase, which is, by this time, already a reactive function, so this one will obviously work. Okay? But now, we're getting into the cool part. I'm going to say, combine it with the echo function, right? So now, I use the pipe symbol to compose two functions together. So again, look at this as more of a two complex problems. I mean, one complex problem, parsed apart, so I implemented, tested, and packaged two of them independently. Now I brought them together into basically one sort of a synthetic function, right? So let's run it. And now we got both echo and hello. And if I decide to do the opposite, echo and then hello, that will work as well. So in other words, it's very easy for us to look at the imperative function as a reactive function. And in fact, the previous version of print load function would always convert everything to reactive. Reactive was more of a canonical model. But we quickly realized that in other applications and other systems that are using Spring Cloud function, it's not always the friendliest way to interact. So we said, listen, if the function is imperative, you should always be able, forget imperative. If you should always be able to interact with function as is, as well as these additional features, right? So, any questions so far? Yes?
I believe implemented way to it when you use flux. How do you accommodate for multi-input?
We're getting there. So the question is about multi-input, multi-output. So we are getting there. There's a demo coming up like in 5 minutes. Any other questions? Yes?
Does the pipe-based model mean that you're pushing the type safety to runtime instead of runtime?
Type safety. Trying to interpret the question. Yeah. Yeah, I mean, okay. All right. Let me kind of deviate a little bit. And hopefully that will answer your question. So here is the class. I'm going to uncomment it. Is a person, right? Okay. So and now I have a function. Where is it? So here's a function that I'm going to use. As you can see, the function signature is now this is not a simple string. The function takes a domain object. So it's called uppercase person. So let's go back to the simple world. And I'm going to say, I'm going to look up uppercase person. Okay, and expect to happen? Let's see. If I try to invoke it like, well, nothing. Tricked you guys, huh? So we got an exception. Let's look at what the exception is, right? So it says, basically, it's clear to me that it's a message conversion exception. Well, it's not just clear to me, it should be clear to everybody, right? Because, again, our opinion that when people communicate Poacher models, right, they send JSON, right? Again, not a requirement, but that's our opinion, which means our default content type right now, when it comes to type conversion, is application JSON. What just happened is that I've sent a string to a function, but now it's a wrapped function through function catalog, right? So which means there's those additional features. During the invocation, it sees that the type, the input type of the function is person. What I have here is string. All right, let's see if I can convert it. And it goes through the registered message converters based on the content type known at the time. And at the time, since I did not provide anything, it says it's application JSON, it applies application JSON message converter, and at this point of time, it bombs out, right? Okay. Now, if you say that if you have some kind of way of converting this to a person, you can register your own message converter with a bean factory and say, and provide either through application properties or by sending a message with a content type header, say foo.bar, foo/bar, that's going to be my content type. And at that point of time, if you implement a message converter that recognizes this content type, it's going to, and this particular code will work. So message conversion, I don't want to say it's an extension point of Spring Cloud function because it's an extension point of Spring Cloud, Spring. Yeah. So Spring messaging. So anyway, yeah, I do. What's in the class path? Oh. You mean which message converters? Well, the class path is the class. Well, this particular project is not the cleanest project in the world. It's a demo from yesterday and everything, but I mean, there is things there, and plus all the JUnit stuff. So it looks like a lot, but yeah, messaging. Well, that message converter is the one that brings Jackson. So in other words, if you decide to implement like a different message converter that JSON message converter that does JSON or whatever, then you can use. So in other words, yes, we provide that by default, you're right, but I know you want to change that, so. I know, and I'm considering it. You say JSON is faster? Is that the thing? Anyway. So let's, I kind of anticipated that this is going to come up one way or the other, so let's send this, okay? Again, I'm still sending a string, but what does my string look like right now? Something that message converter can probably understand, right? So if I try to execute it right now, right? So go back to your question, because I kind of,
So when you're chaining functions using the type model,
yeah.
I guess you can't detect that there is a type compatibility while configuring it.
Yes, but okay. Now with this, here's what's happening. I don't care about type incompatibility because it's either for me to care about type incompatibility, and at that point of time, I have to say that your functions have to be type compatible when you compose them, or because of this message conversion feature, because of the type conversion feature, I'm saying I really don't care about type compatibility because even when you compose functions, right? Let's say I do this. Echo doesn't care what type of string you're going to send, right? So it's going to output the same string, right? But this guy does. But in this point of time, it's going to say, I'm receiving a string as a part of the composition, right? And
Yeah, but you have to have a compile time exception for runtime.
yeah.
You've made a trade-off.
Right, yeah, it is a trade-off. So in other words, the trade-off is either I'm going to disallow typing compatibility or I'm going to delegate it to the runtime. Now, the benefit of this trade-off is you probably discovered these exceptions not at runtime, but at the development time, which is still at runtime, but during the development, and you will register the appropriate message converter. So by the time it gets to production, the possibility of this type of error occurring still possible, but not probable. Okay? Questions? All right. All right. Simple function. Poacher function. We quickly talk about the Poacher function. So let's look at this guy. So we have my function. That's a class. So as you can see, is it a function? Well, not in a literal sense, but it is, right? Because it resembles the function. It has a single public method, takes something, produces something. So it could just as well be a function, and you all need to do is just change this method to apply, right? But I don't have to. I can keep it sort of like a domain specific and so on. So now I'm going to have, where is it? Well, let's just do it. So I'm going to say public my function return new my function, and now I'm going to say that it's a bean. Okay, and I'm going to do lookup on, and what does it do? It just echoes. Okay, but here's the thing. Look how I'm retrieving it. You may implement it as a poacher, but within a framework, to me, it's a function. So and we got everything working, right? And I can still combine it with okay, basically compose it. So that's another sort of a really cool feature of, yes? Say it again? No. Bean configuration for my function is right here. It's basically you have a class somewhere, you just say return new my function. It's a bean. Mm-hmm. Yes. Yeah. I mean, if they're not private, not hidden, then why shouldn't it? I mean, yeah.
How does Spring know that this should be a block as a
How can Sprinkler function know that this should be looked at as a function? Well, no, but that's a great question. So let's kind of try to solve this problem together. So how can we determine that this is a function? We introspect it, right? And we're basically saying, does it really look like a function? In other words, a function, supplier, or consumer, they have certain characteristics, right? When you say add functional interface, like in Java notation, it's pretty strict. It tells you how it's supposed to be, right? So we're basically saying, you have a bean, and you're trying to retrieve it as a function. All right, well, I'm going to say, okay, well, does this bean has a method that kind of looks like a function? And that, to me, basically saying, listen, does it have a method that has a single input parameter and a single output parameter? Well, return value, right? If it does, I'm going to say that looks like a function. But if, let's say, I define, let's try it. Bam. What happened? Well, because this is really not a functional interface anymore. Because it doesn't, look at the contract that function provides you. I mean, defines. It basically says that it basically says one public method, one input, return value. That's it, right? At least in this case, it's a known name. In my particular case, I had a single class that had one public method. So I was able to say, okay, well, I can treat this as a function. It is not a function, but I can treat this as a function. And function catalog provides the wrapper, just like for the type conversion and everything else, to treat this as a function. Because internally, I invoke it via reflection anyway, so. Yeah, if it adheres to the functional interface. But in my current situation, it does not, because it has two public methods, which means I have to say, which one do you want? I have a tie, just like when I had two functions, two functional beans. So look at the exception message. It says, discover two methods that would qualify as functional. And it tells you which method I discovered. So again, exception message kind of tells you what just happened. If I change the second, I don't know, let's try. Actually, I didn't try. There's got to be a test case for that. All right, well, something to work on. Good question. Yes?
So we are passing same parameters to all the functions. We are going to pass different parameters to all the functions.
I'm not sure. We're parsing all. We're getting there. We're getting there. Okay. Oh, no, this is just my implementation. I put everything in it. It's a demo-friendly function. It could be a class somewhere. I just didn't want to jump from one package to another. Okay. So I guess we're going straight into the multi-input, multi-output. All right, so multi-input, multi-output. Now, we just introduced this feature into Spring Cloud Function. And why we introduced it? Because primarily from the community, especially on the streaming side of the community, we were getting requests where people want to be able to either merge certain streams, multiple many to one, or a typical big data use case, one to many. You're reading from the bucket full of data, and you want to say orders go here, accounts go there, and so on and so forth. So let's look at one of those types of use cases. So here's that second case where single input, multiple output. So here's the function that takes, I'm going to use the same integer generator. Here's the function that takes a stream of integers and will output two streams of integers, even and odd, a very sort of a classic demo. Now, how do we communicate multiple inputs and multiple outputs? We had a lot of debates on how to do that, right? And there's still a lot of work in progress. But what we kind of agreed on is to have this canonical representation of multiple inputs and multiple outputs. Now, unfortunately, Java doesn't do a very good job in giving you a collection type classes that allow you to know both cardinality and type. Okay? For example, could I communicate multiple inputs as a time collection or array? Of course I can. But how do I know when I introspect the function, the signature, right? How do I know how many inputs you're actually going to have? And that's fine. Maybe in the specific case of Spring Cloud Function, it doesn't really matter. But for those of you who were in a Spring Cloud Stream presentation, should understand it really matters to me there, because my bindings are triggered by knowing how many inputs or how many outputs I have. If I can't have that information, I can't use your function, right? But even if I, let's say, could use collection or array and say, okay, that problem is solved at least, right? That still doesn't solve the other problem, which is the type. How can you communicate multiple types through a collection? You can't, right? So in Java, unfortunately, never had this thing called tuples, right? But since we already committed very early to Project Reactor, it's a dependency of Spring Cloud Function core, so we kind of stuck with it, right? And obviously, since we have a huge investment in Project Reactor provides us with tuples, up to tuple 8, okay? So if you have a requirement for more than 8 inputs or outputs, I'm going to feel sorry for you, but I can't. So, but I mean, honestly, in all fairness, I mean, if you do have a requirement for more than 8, I would love to hear that, because that's got to be something extremely, extremely complex. So anyway, so we decided to use tuples, and tuples allow me, so if you look at here, I can clearly, when I introspect a function, I have a utility class for that, but when I introspect this function, I can say, I clearly see that this function has 2 outputs, and the types of these outputs is string and string, right? So I have that information extractable from reading the function signature. Now, does it mean that you have to use tuples? Not necessarily. At this point, at the time of me talking, yes, because that's the only way we expose it. But Stefan Deleuze, one of our Kotlin guys, opened an issue, and we're already sort of halfway there with the Poacher functions and a few other things, and the by function, where we will support different programming model. And again, the Poacher function that you saw today is kind of a signal in that direction. In other words, if we come up with a different way of communicating multiple input, multiple output function, okay, then we can use it. But what's interesting is that the internal model is going to remain the reactive tuples. Why? Because, like, in other words, whatever you define, let's say there's another way of doing it, right? But we internally going to convert it through this function catalog procedure to tuples, because I don't want to write different invocation models for each of different types of functions. So it's like bring everything to canonical, but give you flexibility to the, as a user, but internally we're going to bring everything as this, right? But again, if you, so another one of the area we're looking at is the curate function, which is, let's say, function that takes, let's say, flux string and returns function that takes flux string that returns function that takes flux string. So now, actually, tomorrow we're going to be talking about Kafka streams, and Sobi is going to be showing you that. I can convince myself that this is readable, especially if you get beyond 2 inputs or 2 outputs, right? So will we support it? Probably yes. But for example, depending on which type, who you talk in the community, for some people who's been living the functional world for the past 5, 6 years, oh yeah, that's simple. For someone like myself, I'm like, no, it's not. So, but the bottom line is that we will provide that support to kind of satisfy both sides of the community. But for now, we're kind of requesting kindly embrace those tuples. And again, it kind of gives you this linear way. So, I mean, at least from a readability perspective, it's very readable. And like I said, as long as you know, and we know that it's always going to be on your class path, it's not too much to ask. Anyway, I hope I can convince you, and if I didn't, sorry. So, and here's my function. So let's not worry what it does here with Project Reactor, because it's irrelevant, right? It's just an implementation details. Remember that the developer who writes the function, he or she has to worry about this. Me, in Spring Cloud Function, I only have to worry about signature. If you made a mistake there, if there's a bug inside of your implementation, well, you'll deal with that, not me. Okay? So that's kind of a, I mean, I'm not joking. This is sort of a separation of concern. So I care about only this part, because that gives me all the information I need to know how to properly invoke this function. That's all. So, and this function basically what it's going to do, just to quickly, it's going to start receiving the stream that I'm providing, and then it's going to start looking into the stream and say, I'm going to produce 2 new streams and put even numbers here and odd numbers there, and output and basically give you back 2 streams. Now, in the pure functional world, it may not be the most interesting thing to do. But for those of you who were at Spring Cloud Stream presentation yesterday, and I'm going to publish the demos next week, and I'll write a blog and everything, you understand that these streams that were produced were immediately bound to destinations and put on and the data was put on the queue. So as soon as I started the project, it bound to an input queue, it created 2 output queues, and the data started getting there, right? And all you had is just a function. And if time allows, but unlikely, we can do this demo again. So, all right, multiple input, multiple output. So let's see how it's going to work. Okay, so the name of the function will be router, right? Yeah. It's a router. And again, I call it a router because it receives single thing and then routes to different streams the data. Okay, so I'm going to, where's my router? Imagine the amount of cut and pasting I would have to do if it was queries function. Okay, catalog, lookup. Now, it will require a little bit of a setup, so let's just, I have it stashed here. All right. Let's quickly review what we're doing here. So we looked up the function in catalog. The type of the function is flux integer and then tuple2 flux integer, right? So single stream in, single stream out. And then we're basically applying the generated flux, that generator that's going to generate integer every 2 seconds, or 2 milliseconds. And then we're going to have 2 streams. We're going to subscribe and just log the output to the console. Okay? And here we got single input, multiple output. Does that answer your question? Good. And the same goes the opposite direction. So there are test cases. If you go into Spring Load function context, Spring Load function context module of Spring Load function, basically start looking. There's a test cases that basically everything that starts with a multi, there's tons of test cases for multiple inputs, multiple outputs, and combination of both. Questions? Yes? Again, I'm going to like have this sort of, every time somebody asks performance questions, it's really almost impossible to answer on the surface because there's so many ways, so many things that could influence your performance. I need to know your hardware, I need to know yourself, I need to know so many things to be able to even begin to solve the performance problem. But most importantly, I need to know what the SLA is first. Because without knowing where you want to be, I don't know whether it's fast or slow.
No, I'm looking like, is it going to span across this multi-thread or what's happening?
Well, Project Reactor, when it does reactive processing, and this is kind of, again, outside of scope of this presentation, depending on what the type of reactive stream you build, and that's the implementation of the function itself. Depending on how you build the stream, yes, of course, multi-threading could be involved, right? But then again, this is not something we control. What I can tell you is that there are no threads from me invoking the function and anywhere inside of the Spring Load function or function catalog. In other words, we don't create any new threads. But your user code can, and giving the project a synchronous nature of the Project Reactor, depending on what your pipeline looks like, there could be additional threads created. Okay? Okay. All right, so we touched on the functionality. Oh, there's another cool thing I can show you. In the serverless platforms, there was, again, Stack Overflow-driven development that turned into a GitHub issue that turned into a function, routing function. So the complaint was that, oh, all great, we can do these things, but every time I need to be able to map this function or this function or this function, it's a process to go through the UI to map and remap and this and this and this. So the question was, can we have a single function that we're always going to map to, and that function acts as a delegate? So it's not the router that I have right now. It's kind of the inverse, where I have a function already part of the function catalog, always there, and all it does is going to determine based on information that you provided what you really want to do. Like, you didn't really want to talk to me. You tell me who you want to talk to, and I'll connect you to that person, right? So routing functions responsibility is to delegate you to an actual function you want to talk to, okay? So again, as I said, routing function is always there. It's available to you. So, and you can look it up by simply doing this. Okay? So you can look up routing function, and let's execute exactly the same code, this multi-input, multi-output, and see what's going to happen. You got exception. All right, so routing function doesn't really, hold up. Huh? No, it should work because, yeah, it's a bug. It should work. So I'm making myself a note to look into that later. But let's get into something more simple. Okay? I still expect exception, but a different one. All right, the exception again, this is why the previous one, Dave, should work too, because it should have just told me that it shouldn't attempt to interpret the input, rather say, listen, I can't determine what you want to do. So the error message says, failed to establish route since neither were provided. Sprinkle out function definition as message header or as application property, right? Basically, I just invoked routing functions, but I didn't tell you who I really want to talk to, okay? And again, let's just follow the directions of the error message. I'm going to copy this property. I'm going to, and I'm going to say uppercase. That's really what I want to talk to, right? So now, it works, right? So what I haven't touched on, yes. Questions? Somebody just raised their arm? No. Okay. M. All right. There is a list of things. Okay, so now this is static, right? This is one per Spring Boot application, not a very convenient way to route function, right? So let's take it one step further. And again, the same uppercase, but I'm going to do it like this. Okay, so obviously I have to provide the message, but right now I'm going to say builder dot with payload hello, set header, nope. No, I'm sorry, not content type. What am I doing? Jesus Christ. Yeah. Quickly, for those of you who may have used Spring Cloud Function before, we used to have the property called function.name. It still exists. It's going to delegate. It's going to turn. There's an environment post-processor that will turn it into function definition. The real reason is the definition is more representative of what we're really doing, because right now, when you're dealing a single function, okay, function name, but if you're doing function pipe, function, you're actually defining a function, so it kind of makes more sense. And again, also because Spring Cloud Function just kind of bring that uniformity that we use across multiple cloud projects. So just a quick note. All right, so, okay, no. Oh. This is one thing I wish people would standardize on the builder API. Some people have build, some people have get. So apply. Quickly on the message. So I'm not really sending the message somewhere, whatever. Like I said yesterday, message is just a structure that allows me to not only communicate the actual payload, but some meta information. So, and internally, we look inside and say, listen, if it's a message, good, we're going to try to see if we can pull some other data. If it's a Poacher, it's a Poacher. But again, I'm sending a message. My uppercase is a string. Again, type conversion, we're going to say, you're sending me a message. I have a string. I'm going to say, OK, well, and that's a convention that actually driven from Spring integration from a while back. We're going to say, OK, well, if you have a Poacher as an input parameter declared and you coming in as a message, we're going to assume it's a payload. So we're going to extract the payload, compare the types. If types are compatible, we're going to invoke. If not, we're going to convert and then invoke. And that's it. So, but in this case, I'm becoming more dynamic because I'm providing this function property on a per message basis, which means on a second message or subsequent message, I can call a different function or specify a different function. And we're still working, right? So. No, not. I turn it off. Yeah. So, and the other thing is that if we go back to the error message, I'm forcing the error message because I forgot the exact name of the property. I want to cut and paste. When you have messages, or not, doesn't really matter, we have this thing called spell, Spring Expression Language, which just the code snippets that you can execute. And as long as so there's a property called Spring Cloud Function routing expression. As long as it returns, basically it returns a string value. It should return a string value, and that string value should correspond to a function name that you wanted to invoke. So basically, I can change this, and without getting into the complex expressions, all I have to do is provide this property, wrap uppercase in the proper valid expression, literal expression. But again, for those of you who are familiar with spell, the sky is the limit. You can include a very complex spell as long as it evaluates to something that is a function within function catalog. Everything will work. And again, it's very important. It's like a lot of these requirements are driven by the frameworks that use Spring Cloud Function. So streaming use case was one of them. All right, guys, I have like 6 minutes left. So I'm going to show you one other feature of Spring Cloud Function, which I believe is extremely valuable. And again, those demos are a bit more simpler because they're preset. So function deployment is something I did not show yesterday because it was outside of scope of Spring Cloud Stream, but it is kind of relevant to understand how you can interact with Spring Cloud Function and what additional value it brings to you. So let's say we already saw how you can implement classes, beans, and so on and so forth. But let's say you have a package, a jar or exploded archive package, and that package has a function. Notice how I'm not providing you with any details of what does it mean has a function. because we support a variety of different paradigms. It could be just a class function, and you can point to a class. It could be full-blown Spring Boot configuration. It could be full-blown Spring configuration, non-boot. It could be some other configuration. In other words, if we can extract your function based on limited directives from you and load it into our function catalog. So basically, you have a package which will start, will identify a separate class loader so there's no type collusion or whatever, so you can have the entire application with its own class path and everything, and it contains a function, and we're going to load this function into our function catalog, properly handle the class loader issues, and invoke this function. So let's look at some of these examples. So again, for more, you can look at the Spring Cloud Function deployer module, and but I have a bunch of different applications here for a variety of different test cases. So the first one I'm going to look at is deploying class. This is the simplest scenario. You have non-Spring, non-function, nothing. You just simply have an application. It's called deploy class. So simple as Java. So where is it? OK, here we go. So I'll show you the code real quick. This is it. That's the entire jar, right? No Spring, nothing, OK? So what I'm doing here is, it's already packaged in the jar. I did it before the presentation. I'm simply specifying Spring Cloud Function location property and Spring Cloud Function function class property, OK? And I'm going to run it. And it's uppercasing hello, OK? And the other level of extreme is the full-blown boot app, which, where are we? So deploy boot app. Let's look at this one. So deploy boot app. Notice how we do not specify location. I mean, we specify location, but we don't specify function class, because at this point of time, in this particular boot app, there's a Spring configuration. Functions are going to be loaded into Spring application context. However, it may or may not have its own function catalog. But remember, that function catalog or that application will sit in a different class loader. So we cannot really cast that catalog to our function catalog. But we can extract the function and load it. Remember how I told you about function registration? I can pull the function out, load it into the function catalog. And again, I may be giving you more details, because the bottom line is that there's an application somewhere over there that's been deployed. Deployer recognize it, pull the function, and allow you to use that function as if it was a local function. So I mean, the function is the same uppercase, but let's boot app. Let's look at what's going on here. So it's uppercase function, but as you can see in this particular case, it's a full-blown Spring Boot configuration, and it has a function declared as a bean. And in my demo, I'm doing the same thing, just saying, here's a location. And then remember, I'm still doing function catalog, get bean, function catalog, look up function. And again, this is, again, another beauty of Spring Cloud, of function, not even Spring Cloud function, because whatever is there, remember, there is, aside from the two class loaders between the deployed jar and local deployment, there is still the same JVM, which means certain classes are still shared. And that's where the true value of having functions as Java strategies really resonates, because I may not be able to cast it to exactly the function implementation that you have there because of the class loader differences, but I can always cast it to a function and invoke it as such. Okay, so let's run it. And that's it. And I have 7, 6, 5, 4, 3, 2, 1, 0. Guys, thank you very much. I hope you enjoyed it. I'll be hanging out there, and